You already took your 4-1 to 4-4 quiz, and today we're going to do a quick review, we're going to do a warm-up, and then we're going to start some scatter plots. So please hit pause, and please do the warm-up, and then I will go over the answers. Now that you've done the warm-up, you know that number 1 is a continuous graph. Because it is a continuous graph, your domain is way on your x-axis. It goes all the way from 0 all the way to 4 and covers everything in between. So it's 0 is less than or equal to x is less than or equal to 4. Your range is your y-axis. It goes everywhere from 0 up to 4 on your y-axis. So 0 is less than or equal to y, which is less than or equal to 4. Number 2 says graph the function for the given domain. Remember, domain means dots. After you substituted all of these values in, you should have had a table that looked like this. -1, 0, 1, and 5. And you got 10, 5, 2, and 10. So when you went and graphed it, and because it was squared, you knew it should somewhat look like a U, but not connected. So you have -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 5. 1, 1, 2, and 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can kind of see the U shape. This one says graph the function. I personally chose, if you look, it is the exact same thing as number 2, so I just chose these ordered pairs and said -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 5, 1, 1, 2, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you know it's going to form some sort of U. So then this one you would connect because there was no domain. Now today we're going to do scatter plots, which I know you did in 7th grade, and they're very, very fun. What a scatter plot is a scatter plot shows relationships between 2 sets of data. We are going to use the given data to make a scatter plot of the height and weight of each member of a basketball team. Well, the first thing that you want to decide is what is your independent and what's your dependent variable. Does the weight depend on the height, or does the height depend on the weight? Well, I usually think that the weight of somebody depends on their height. So this would be my y because it's my dependent. And this would be my x because it's my independent variable. So the first thing you want to do is you want to give a title and label your axes. You will not get full credit if these are not there. I would maybe say a good title of this would be basketball players height and weight. So we have a title. Let's label our x-axis height in inches. Make sure you put in inches. Height in inches over here. And then this is my weight in pounds. Notice we only have the first quadrant of coordinate plane because you're not going to have negative height or negative weight. Now, let's look at our height. Let's look at our smallest value is 68, and our largest is 74. Now, if I would start at 0 and go to 68, that'd be kind of hard. So what you can do is you can put your 0 here, put a break in the graph, and then let's go and start at 68. And let's look from the largest to the smallest, 74 minus 68, that's just 8, since the difference between the large and the small. So large minus small equaled 8. So let's use a scale of 1. So let's go 68, 69. Use different colors, kind of easier to see. 69, 70, 71, 72, 73, 74. Now I typically would go below, but since just the screen doesn't go that low, that's why. So typically put your numbers below for your graph. Now when I look at my y-axis, I know that my smallest is 160 and my largest is down at 190. Again, I'm going to want to put a break, but if I'm going from 190 minus 160, that's 30, I'm probably going to go by 5s. So let's start at 160, 165, 170, 175, 180, 185, and 190. So now that we've done everything, we have a scale of 1 there because it was less than 10. When it was bigger than 20, let's just go by 5, so that was pretty good. And now let's go ahead and plot our points. So we had 71, 170, so if there's 71 inches, it goes all the way up here at 170, plot your point. At 68, it was 160 pounds. At 70, it was 175 pounds. This person who was 73 inches tall, they weighed 180 pounds, so up here. And when they were 74 inches, they were up at 190. So we have a bunch of dots. We're not going to connect them yet because we're first going to talk about a couple of things. Every single scatter plot has something called a correlation. And a correlation describes any type of relationship between two sets, aka a scatter plot. A line of best fit, another name of this is a trend line, is the line that comes closest to all the points on a scatter plot. One way to estimate the line of best fit is to lay a ruler's edge over the graph and adjust it until it looks closest to all the points. Notice we have positive correlation. They're both going up, and the line is in the middle. If you count it, there's 1, 2, 3, 4, 5 dots. 1, 2, 3, 4, 5. There's 6. There's about the same number of dots on both sides. Here we have a weak positive correlation. This has no correlation. It just looks like snow everywhere. It's not going up or down. Our negative correlation, as one data increases, the other one decreases. Let's look back at our basketball graph. Is this a positive or a negative correlation? I would say that this is a positive correlation because as the height increased, so did my weight. Now, if I were drawing a line of best fit, I'm going to go ahead and get my line out here. My line drawer, and nope, that's not what I wanted. That's not what I wanted. This is what I wanted. My line drawer out. I'm going to use with one arrowhead. I'm going to start it. It doesn't necessarily need to start down there, but my line needs to go through. Let's see. If I put it up here, is it through the center? No. Is it here? No. But if I put it about right there, you can see that there's 1, 2 on one side, and there's about 3 on the other side. So if you look, it goes through the center. Now we're going to do some sets of data to see what kind of correlations we have. Part A says the size of a baby jar and the number of jars of baby food a baby will eat. Well, first let's decide what's my independent variable and what's my dependent variable. So it says the size of the jar of baby food and the number of jars that the baby will eat. Does the size of the baby jar depend on the number of jars, or do the number of jars that it eats depend on the size of the jar? Well, I think that the number of the jars that the baby eats depends on the size. Think, if a baby jar is massive, they're probably going to eat one, but if they're itty bitty, they might eat more. So I want to ask myself, I'm just going to draw myself a little graph. If I have the size and I have the number of jars, let's think. As the size increases, what's going to happen to my number of jars? It's going to decrease the number of jars you'll eat. So because as one increases, the other decreases, this is going to be a negative correlation. Another way to think about it could be if you write size here, because that's your independent, and the number. As the size increases, the number decreases. Think about it as a positive and a negative. Positive times negative equals a negative. How about the speed of a runner and the number of races she wins? What is my independent variable? Does the number of races they win depend on the speed, or does the speed depend on the number of races? Well, I think that the number of races depends on their speed, so this would be my independent. So I'm just going to go ahead and say speed and wins. As the speed increases, what do you think is going to happen to their number of wins? That will also increase. So this is a positive correlation. The next one says the size of a person and the number of fingers they have. Do one of those even depend on the other? Absolutely not. So there is no correlation. Example 3 says, choose the scatter plot that best represents the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the oven. So it's been taken out. You have to pay attention to every little word. So does the temperature depend on the number of minutes, or does the number of minutes depend on the temperature? Well, here's a clue. Anytime you have time, it's always going to be your independent. So I would maybe ask myself, time and temp, to figure out what type of correlation. As the time increases that your pie is out of your oven, so your oven has nothing in it, what's going to happen to your oven temperature? It's going to go down. So we need to find the graph that has a negative correlation. Clearly it's not graph C. What's the difference between A and B? Well, here we have negative time. Can you really have negative time? It's time after it's been taken out. So you can't really have the negative time. No negative time. So that's gone, so your answer is A. Last but not least, we can use scatter plots to make predictions. That's one of the main things of how they're actually used. So we are going to do that. It says, use the data to predict how much a worker will earn in tips in 10 hours. Well, first, we always said that your time is your independent and your tips are your dependent. So the tips depend on the number of hours. That makes sense. So I'm going to go ahead and label my axes. This is my tips. Make sure you put that it's in dollars because we live here in America. And this is the hours. We can even put hours worked. And a good title of this might be, let's think here. Use the data to predict how much a worker will earn in tips. How about money earned in tips? Now let's look at our X. The smallest is 2, and the largest is 11. That's only a difference of 9, so I would just go by ones here. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here my smallest is 7, and my largest is 26. So I might want to go by something a little bit bigger. That's 19. Since it's 19, it's a little less than 20. Let's go by maybe 2s. So we have 0 still here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Now let's just go ahead and plot. We have 4 12, so over to 4, up to 12, plot your point. 8 20, over to 8, up to 20, plot your point. 3 7, so they worked 3 hours and made $7. They worked 2